Apalachicola Bay is a major producer of seafood for Florida and the United States. Comparing production per acre, it is one of the most productive estuaries in the Northern Hemisphere. But seafood production is dependent on much more than the bay system itself. Estuaries, where rivers meet the sea, have evolved over thousands of years, and each has its own characteristics and separate identity. One of the main factors in determining the character of an estuary is the amount and pulsing of fresh water that enters it. The fresh water establishes a mixture with the open seawater that is critical to the survival of estuarine species. For the Apalachicola, the natural pulsing, flooding of fresh water transports nutrients from the floodplain to the estuarine food web, which produces oysters, shrimp, crabs, and fish for human consumption. Fresh water combined with climate, the shape of the uplands, the shape and depth of the bays, and the number and variety of plants and animals characterize an estuary. With the possible exception of climate, man has the ability to drastically alter most aspects of an estuary. Because evolutionary trends and adaptations are a long time in the making, man's rapid alterations almost invariably decrease production. The Apalachicola National Estuarine Research Reserve is part of a national program designed to protect estuarine systems. The reserve serves a coordination role between federal, state, and local government and resource users. The reserve is a research and education facility. Technically, the Apalachicola River begins at the Florida-Georgia state line as the water comes through the Jim Woodruff Lock and Dam. Functionally, it has two beginnings, one some 80 miles above Atlanta in the southern range of the Appalachian Mountains. This is called the Chattahoochee River. The other, called the Flint River, begins in a developed area close to the Atlanta airport. Because of human territorial concepts, the name of this great river changes as it crosses political boundaries. More importantly, the management strategies that govern the use and abuse of our finite water resources also change. The land area or watershed that ultimately feeds the Apalachicola estuary is affected by management strategies far removed from the estuary. Although by far the largest river in Florida in terms of volume of flow, the Apalachicola is a slow, lazy, winding river. The river drops only the height of a four-story building in its 107-mile trip from Georgia to the Gulf of Mexico and discharges an average of 16 billion gallons of rich, fresh water into Apalachicola Bay each day. The range of flow is more impressive than average. Low flow at the mouth of the river would fill a football field over 2 miles deep, and record high flow would fill the field 102 miles deep every day. Rainfall in Georgia and Alabama has a much greater influence on Apalachicola River than Florida rainfall. The Chattahoochee River drains almost three-quarters of the 19,800 square mile basin. Combined with the Flint River Basin, 88% of the land area in the river basin lies outside the state of Florida. Based on average flow, 84% of the freshwater feeding Apalachicola Bay comes from the states of Georgia and Alabama. The Chattahoochee River Basin is longer and narrower than the Flint River Basin, and its headwaters extend into the Appalachian Range. Because of this, snowmelt is part of its flow. Abundant rainfall in its upper basin combined with a steeper slope give the Chattahoochee River the hydrologic characteristics of a mountain stream. On the other hand, the Flint River flows across relatively flat terrain. The Flint River is spring-fed to an appreciable extent, hence the flow of the Flint is more uniform than that of the Chattahoochee. Because of the distribution of rainfall in the watershed and the size of the drainage basins, the average flow of the Chattahoochee River exceeds that of the Flint. This means the Chattahoochee River contributes the major portion of peak floods to the Apalachicola River. During the lower flows, the proportion contributed by the two rivers becomes more equalized. During periods of extreme lows, the spring-fed Flint River becomes the dominant source of water to the Apalachicola. This is the way the natural system functions. However, man's alterations have changed nature's ways. There are now 16 dams on the Chattahoochee and Flint rivers. In an attempt to hold water for drought conditions and build along the banks, we strive to stabilize water flow. Holding of floodwaters and slow release seems harmless and in some cases even beneficial. However, the long-term trends of seafood productivity in Apalachicola Bay have evolved a system almost totally dependent on detritus, dead, decaying plant matter. The annual plant material production of the Apalachicola River swamp rivals the production of such cultivated crops as corn and wheat, and is the basis for the commercial seafood food production. This detrital food web is a free, renewable resource, but for man to continue to benefit from it, it has to be transported via floodwater into the river and bay. Although essential to high seafood production, floods are a mixed blessing. Man's shoreline structures may be damaged or destroyed, and because disease-causing bacteria are also carried by these floods, oyster harvests may be halted for short periods. Floods offer unusual problems for land animals. These deer were isolated by rapidly rising water and are miles from any upland areas except for small high spots, some of which are prehistoric Indian middens. These deer fell prey to large alligators that are now able to roam the flooded swamp in search of food.
In its lower portions, particularly on the east side, the Apalachicola River breaks up into a series of distributaries, forming a vast delta marsh. Sediment transport via the river into the estuary is such that the delta grows 3 to 13 feet into the estuary each year. This tremendous volume of sediment makes the Apalachicola the only estuary on the Gulf Coast with the potential of filling in completely. The estuarine marsh serves several functions. It increases productivity in the bay by supplying additional nutrients. The marsh operates as a filter, preventing pollutants from entering the bay. Probably its most noticeable function is its role as a nursery for larval and juvenile marine organisms. Particularly in the spring and summer months, every handful of water observed is literally teeming with life. Under a microscope, it is amazing how much life can be found in a drop of water. This microscopic life represents the second stage of the detrital food web and ultimately leads to commercially harvestable seafood. The marsh plays a vital role in shoreline protection. It decreases erosion and, due to its tremendous water storage capabilities, decreases structural damage during major storms. The Apalachicola Estuary, encompassing 155,000 acres, is a lagoon and barrier island complex. It has been classified as a shallow coastal plain estuary oriented in an east-west direction. It is 55 miles wide and is only 6 miles across in its greatest north-south dimension. The Apalachicola Estuary is bounded on the Gulf by 4 barrier islands: St. Vincent's, Cape St. George, and Dog Island. In addition to being beautiful, these islands serve a functional role. Barrier islands slow the mixing of the rich freshwater, allowing time for the nutrients to be incorporated into the estuarine food web. Tides, too, play a major role in estuarine mixing. While an average of 16 billion gallons of fresh water enters the estuary, 700 billion gallons leave on daily falling tides. Apalachicola Bay tides are complicated by several factors. First, the system is located in an area between diurnal, 2 tides per day, and semi-diurnal, 4 tides per day, so it experiences mixed tides. Although 2 or 4 tides are the norm, Apalachicola Bay can exhibit between 1 and 5 tides each day. The prevailing water current in Apalachicola Bay is from east to west, and this relatively stable current also affects the tides. The bay is shallow, averaging 9 feet, and reacts quickly to changes in wind direction and speed. Winds from the south or west, especially the south, can greatly increase the high tide or nullify the low. Winds from the north and east, especially the north, can enhance the effect of the low tide or nullify the high tide. High and low river flows also affect the range of tides.
The most well-known group of animals in the estuary are those harvested for human consumption. Apalachicola Bay routinely produces 90% of Florida's oyster crop and accounts for over 10% of the nation's harvest. Between 4 and 6 million pounds of oyster meat are harvested during normal years from the bay. Storms, drought, and overharvest in recent years have sometimes reduced the catch. Dockside value of the oyster crop is approximately $6 million per year. Shrimping is economically more important than oystering, but employs fewer people. Together, the shrimp and oyster industries are the backbone of the area's economy. At the consumer level, the oyster and shrimp industry is estimated to be worth $70 to $80 million to the economy of Florida and the nation. Apalachicola Bay also supports major blue crab and finfish industries. Although economically important, they are dwarfed by the oyster and shrimp industries. The economic value that can be proven by dockside value is impressive, and the more subjective retail value is even more impressive, but they don't come close to telling the story of the importance of the Apalachicola estuary. Many species, particularly the shrimp, crabs, and finfish, only spend a portion of their lives in the estuary. Blue crabs, for example, migrate as much as 300 miles to spawn in the Apalachicola estuary. They spend their larval and juvenile stages in the marshes, then scatter over the Gulf. So do the shrimp and finfish. They are caught somewhere else, landed somewhere else, and are reflected in someone else's dockside value. But that product would not be there if Apalachicola Bay loses its productivity. The Apalachicola River Basin is also rich in natural resources other than those of economic importance. Part of the role of the Apalachicola National Estuarine Research Reserve is natural area inventory. How many different kinds of plants and animals exist in the area? To date, 1,362 species of plants have been identified in the Apalachicola River and Bay drainage basin. 103 of these are listed as threatened or endangered species, and 16 can be found only in Florida on the Apalachicola floodplain. A new species, the Apalachicola daisy, Boltonia apalachicolensis, was recently discovered. 86 species of fish have been identified from the Apalachicola River, and roughly 100 more can be found in the estuary. 3 species of fish are listed as species of special concern: the Atlantic sturgeon, blue-striped shiner, and shoal bass. The city of Apalachicola historically supported a sizable sturgeon caviar industry. Sturgeons are anadromous fish, which means they spend part of their life in fresh water and part in salt water. The portion spent in fresh water is the egg-laying stage, and like the salmon, their spawning runs are far upriver. The dams on the Chattahoochee and Flint rivers prevent the sturgeon from migrating to their historical rocky spawning areas upriver. Not only was the caviar industry lost, but the sturgeon is now rare on the river. 57 species of mammals can be found in the Apalachicola Basin. Threatened and endangered mammals include the black bear, probably the Florida panther, the West Indian manatee, and 2 species of bats, the Indiana and gray. Within the basin, 315 species of birds have been identified. This total is a very high species count for such a relatively small area, but may be explained by the natural elements within the estuarine system. Habitats within the reserve include cypress swampland, deciduous and coniferous forest, brackish marshes, extensive dunes, beaches, and savannas. These habitats support an amazing variety of plant communities and thus are capable of supporting exceptional bird populations. There are 20 bird species found in the reserve which are listed as threatened, endangered, or of special concern. The Apalachicola Basin boasts the highest number of amphibians and reptiles in all of North America, north of Mexico. The list includes 46 species of amphibians and 83 species of reptiles. Habitat diversity and direct river connection to the Blue Ridge Mountains accounts for the high species diversity, particularly of turtles, frogs, and salamanders.
Although Franklin County, surrounding the Apalachicola estuary, is 545 square miles, with an estimated 1990 population of only 9,000 people, population growth here and upstream represents a major threat to the natural resources of the estuary. 3/4 of the drainage basin feeding the estuary is in Georgia, 1/8 in Alabama, and only 1/8 in Florida. With increasing population and multiple, sometimes conflicting demands for finite water resources, basin-wide management becomes an extremely complicated and important. Any attempt to protect and manage the natural resources has to include all 3 states and recognize the Apalachicola estuary as a user of fresh water. In addition to birth rate and increasing longevity, 34 people move to Florida each hour. Since 1983, Florida has increased by an average of approximately 325,000 new residents each year. That number represents twice the population of Tallahassee and Panama City combined. Most of our new residents choose to live on or near the coast. Added to the permanent Florida population, from an environmental standpoint, are the effects of 40 million tourists in 1989. Land surrounding the Apalachicola estuary is beautiful and relatively cheap for Florida lands. Decisions are now being made that will determine the future of the system. Decisions are being made in Georgia, Alabama, and Florida. For Florida, the questions are the same as those pondered earlier for Tampa Bay, Biscayne Bay, Pensacola Bay, and many others. The question, will we risk the trade of the natural resources and our present economic base for growth and economic diversity? The effects of the coastal management decision process can be demonstrated by comparing it to the consumption of a pie. Decision makers remove the pie from the cupboard and agree that it's a great pie and should be conserved to share with future generations. They only allow one small piece to be consumed. The rest is set aside and protected. Later, a new set of decision makers again removes the pie. Only now it's considered to be a whole pie again. The smaller circumference is unnoticed. With the same well-intentioned mental process, another piece is consumed. Taking the analogy back to the environment, when enough pieces have been consumed, the functional relationships of different habitats are lost, and the naturally high productivity ceases, At best, we have a small natural museum, a window to the past, and we will wonder how we lost such a great pie. There are numerous case histories dealing with the loss of productive estuarine systems due to pollution, overuse, competing and incompatible uses, and economic diversification. The Apalachicola system is still productive and has the best chance nationwide of remaining productive for the use and enjoyment of future generations.